should already be open.
Alright, so I'm Kelvin.
I'm Michelle.
And our project was to create a system that would enable the automated navigation and mapping of tunnel systems with the use of IR sensors and what's called the wall follower algorithm.
So our purpose for starting this project was to make a robot that would be able to navigate through a maze, or like a tunnel system really. And we had four main goals in mind. Our first was to use infrared sensors to be able to recognize and check walls. Our second was to be able to build a digital map of the robot's progress. And our third and fourth were to use photoresistors and LED lights to be able to detect any dark areas.
So to implement these goals, we had a set procedure. The robot begins at the beginning of the entrance of the maze, and before it makes its moves, it will scan the area and use that input data to determine where it moves. And every time it moves, every time it picks up a wall, it will both draw a trail of where it was in form of these yellow squares, and the walls will be represented as black rectangles. And also because our ultimate purpose of this project would be for data collection and research purposes, we also added an Arduino on top, which has 4 LEDs that light up in dark areas, and those areas will be indicated with the gray fill-in squares. And so, assuming all goes well, the end state of this procedure will be that the robot returns to where it entered with the maze fully mapped out.
For the hardware of this project, we primarily used a Parallax Scribbler 2 robot. Attached on top of it was an IPR Fluke 2. And on the IPR Fluke 2 were Bluetooth capabilities as well as the IR sensor that we used to detect walls. On top of our Scribbler, we had an Arduino Uno that powered a photoresistor and 5 LEDs. As for the software, we imported a Miro library into Calico Python, and we used Arduino C. And here's an example of Arduino C code. This is the loop that we used to turn on the LED lights. Whenever the photoresistor picked up values that were under 680, it would turn on all 5 LED lights, 4 of which are headlights in the front, and 1 that's in front of the light resistor on the Scribbler in the back.
And here on the left is a slice of our Python navigation algorithm. So what it does is first it tells the robot to move forward, then it looks left, center, and then right. And every time, or whenever the infrared sensor detects that there is no obstruction in the way, it will move forward and start all over.
And on the right, we have a little bit of our mapping code. And what we do here is we use an XY grid to keep track of the robot's position on the blank image file. And we do this based on how big the actual image is, and by dividing it up into a grid. And after that's done, whenever it picks up a wall, it'll actually use 2 nested for loops to change the color of the pixels in that area that's designated by the loops into black. And then it will take these arguments based on, once again, the size of the picture and the orientation of the robot. So here's our circuit diagram for the Arduino Uno. As you can see, we have a simple photoresistor circuit as well as 5 LEDs placed in parallel with 150 ohm resistors in front of each one.
And here's our demo video so you can see our robot in action. So right now the robot's just going to move forward, and it'll check the wall every time it moves forward. Whenever it detects blank space in front of it, it'll go in that direction. It uses the IR sensor to see if there's an obstacle in front of it. And then it will produce this map on the computer screen. And then whenever it enters a dark space, like a tunnel, then it will turn on the LED lights, and when it exits, it will turn on. The tunnels are indicated by these gray squares over here. And it uses this thing called wall follower algorithm, where it basically just hugs the left wall, and eventually it'll make its way around the entire maze and exit where it came from. It remembers where it came from using XY coordinates, and then when it exits from its original position, it'll just stop. And this is the completed map at the very end when it exits.
So we ran into a few challenges while working on this project. Our first was our navigation. So originally we were planning to use 3 infrared sensors pointing in different directions, but because that would be costly and inefficient, we decided to go with 1 that would turn in different directions. Our second was connecting our Arduino Uno with our Scribbler. So instead of actually writing in code that would connect the 2, we decided to use an LED light that would activate in dark areas, which the Scribbler would handle with its light sensors. And our last problem that we still have are inconsistent angle, because the wheels on the Scribbler move slightly. Every time it turns, overall position deviates.
So what can this technology be used for? Although our project isn't exactly industry standard. There are very real applications for this type of technology. For example, obviously we talked about research for places such as animal burrows, cave complexes, anywhere that a human doesn't really want to be. And along the same lines, there are other uses that are very relevant to all of us, including emergency rescue teams and the military. And basically, these robots have almost unlimited potential, and they could do a lot to keeping our soldiers, civilians, researchers safe.
In conclusion, we did successfully create an autonomous robot that could travel through a maze and figure out where its locations are while also producing a map that was generated onto a computer. However, there are still many improvements that we can make to this prototype. In the future, we hope to be able to make our robot move faster because the one that we currently have moves kind of slowly. And we want it to be able to traverse through uneven terrain while also being able to photograph walls while it's in places such as tunnels, and then also be able to move obstacles out of its way with possibly a crane of some sort.
And we would like to thank our professors, our teacher fellows, and TAs, and